Hello friends, myself Rajendra Mahajan presenting my video on vector calculus on Green's theorem. Example, verify Green's theorem for f bar is equals to that vector function is x square plus 2xy into I plus y square plus x cube y into j over the square whose vertices are at 0 0. First one is at 0 0, second at 0 1, 1 0, third at 1 1, and fourth 0 1. Therefore, here, this problem is to verify the Green's theorem. And for that, first of all, we try to show that square in this xy coordinate system. The first point is O, suppose, whose coordinates are 0 0. Second one is 1 0. Third one is 1 1. And fourth one is 0 1. Then joining this by straight line, we get this square OA, B and C, and arrows anti-clockwise direction, means from O to A, then A to B, B to C, and then C to O. In this direction, we have to perform the line integral. Then, by Green's theorem, its statement is like this: line integration of m dx plus n dy over the curve C is equals to double integration of dou n by dou x minus dou m by dou y, dou n by dou x minus dou m by dou y with respect to xy over the region R. Means to verify this Green's theorem, we have to obtain left hand side by performing line integration and right hand side by performing double integration over the closed region. Here that closed region is a square. Given f bar is equals to, once again I will write x square plus 2xy into I, y square plus x cube y into j, and dr bar is equals to dxi plus dyj for two-dimensional figure. And then when we take a dot product of f bar dot dr bar and its integration, it becomes integration of dot product means a1 b1. Here that f bar is x square plus 2xy into I plus y square plus x cube y into j. This is the first vector function. A dot product with another vector function, that is dxi plus dyj. And as per the definition of dot product, it is equals to a1 b1 plus a2 b2, means it is integration over the curve C as x square plus 2xy into dx plus y square plus x cube y into dy, and we call this as equation number 1. This is equals to m dx plus n dy, nothing but m dx plus n dy. Therefore, that value of m dx plus n dy in integral sign as x square plus 2xy into dx plus y square plus x cube y into dy, and then comparing these two integral, we get the value of m as coefficient of dx, means it is or as per the figure, when we have to evaluate this line integral, it is sum of that four line integrals along OA, then along AB, along BC, and then along CO. And we call this equation number 1. And then when we perform line integral along OA, it is on x-axis, whose equation is y equals to 0. The equation of that straight line is y is equals to 0. Differentiating it, we get dy equals to 0. And then substituting this in that integral. Therefore, it is integration of x square plus 2xy dx plus y square plus x cube y into dy. And as dy is equals to 0, that second term becomes 0. Therefore, we get only x square dx. That's 2xy also becomes 0. Therefore, only x square dx. And between limit x equal to 0 to x is equals to 1 as per that direction of that straight line. Therefore, it is x cube by 3. Integration is x cube by 3. Limit from 0 to 1. 1 by 3 minus 0, nothing but 1 by 3. Value of that first line integral. Then along AB, equation is line parallel to y-axis is x is equals to some constant. Here x is equals to 1. Differentiating it, we get x equals to 0. Substituting it in that integral, x square plus 2xy dx plus y square plus x cube y dy. Put x is equals to 0 and dx equals to 0. First term becomes 0 and second term becomes y square into dy. Y square plus 1 into y dy, and then integrating it between the limits as per that direction, it is from 0 to 1. Y equal to 0 to y equals to 1. And therefore, integrating each term with respect to y, we get y cube by 3 plus y square by 2 and limit from 0 to 1. It is 1 by 3 inside, 1 by 3 plus 1 by 2 minus lower limit at 0. And therefore, it is 2 plus 3, that is 5 divided by 6 is the value. Then next, along BC, a line parallel to x-axis whose equation is y equal to 1, constant term, dy equals to 0 therefore. And substituting it in that line integral of along BC as x square plus 2xy dx plus y square plus x cube y into dy over BC as, therefore as dy is 0, second term becomes 0, we have only x square dx. X square plus 2x into 1 means x square plus 2x, and its integration with respect to x between limits as per the direction, it is from 1 to 0. Yes, if we see this, it is from 1 to 0, and therefore integrating, we get x cube by 3 first term and second term as 2x square by 2, 2 to get cancelled, and limit from 1 to 0, it is 1 by 3, 0 upper limit minus lower limit 1 by 3 plus 1, it is 3 plus 1, which is 4 by 3 with minus sign, means it is minus 4 by 3. Then lastly, along CO, nothing but y-axis. Equation is x is equals to 0, dx is equals to 0. Substituting that in this integral, we get that line integral as first term becomes 0. We have y square into dy only, and limit from, it is from 1 to 0 as per the direction, anti-clockwise direction. Integration is y cube by 3, limit from 0 to 1. 1 by 3 minus 1 by 3 we take outside, upper limit 0, lower limit 1. Therefore, it is minus 1 by 3. Therefore, taking the addition of all these 4 line integrals, we get the value of left hand side as nothing but integration of m dx plus n dy, as the first value is 5 by 6, 1 by 3. Second line integral is 5 by 6. Third one is minus 4 by 3. And then minus 1 by 3. Therefore, if we take a LCM of the first two term, it is 6. 2 plus 5 and minus 5 by 3. 4 plus 1 we get 5. And therefore, LCM of this two term is 6. 7 minus 5 to the 10. That is minus 3 by 6. Nothing but minus 1 by 2. This is the value of LHS. We call this equation number 2. Or equation number 3. Then here half part is completed. Then we have to find the value of right hand side by performing that double integration. Here line integration of x square plus 2xy into dx plus y square plus x cube y into dy. Comparing with m dx plus n dy, integration of that, we get the value of m as x square plus 2xy. Differentiating it with respect to y, keeping x constant, we get its value as 2x. N is the coefficient of dy, y square plus x cube y. Differentiating that n with respect to x, keeping y constant. Therefore, we get 3x square y. Then value of dou n by dou x minus dou m by dou y. Dou n by dou x is 3x square y and minus 2x. And therefore, double integration of this term, RHS is nothing but double integration of this term 3x square y minus 2x with respect to xy over the closed region R. And to obtain the limits, we have to draw a strip either parallel to y or parallel to x. Here I am making it parallel to y axis, whose lower end is on x axis and upper end is on that line BC. And then moving it from this y axis to that line AB, so that we can cover this complete region, which we are calling as a region of integration. And therefore, as the strip is parallel to y axis, your first integration is with respect to y. Therefore, 3x square y minus 2x with respect to y between the limits y is equals to 0 to y is equals to 1. That line BC, equation is y is equals to 1. Therefore, these are the inner limits. Then we have to move that strip from starting point to the end point of that region. Therefore, the starting line is nothing but y-axis, whose equation is x is equals to 0. Therefore, x is equals to 0 to the last point, where x is 1, x is equals to 1, and then outer limit as it is 0 to 1, integrating each term with respect to y for the inner integral, we get 3x square y square by 2 minus 2xy, limit from 0 to 1, and then its integration with respect to x after substituting the limit 0 to 1, 3x square by 2, upper limit 1 minus lower limit 0, minus 2x, again 1 minus 0, and then its integration with respect to x. It is integration of 3 by 2 x square minus 2x. Integrating each term with respect to x, we get first term 3 by 2, that constant term we take outside. Integration of x square is x cube by 3 minus 2 constant. Integration of x is x square by 2, limit from 0 to 1. And therefore, substituting the upper and lower limit, 3 get cancelled, we get 1 by 2 or x cube by 2 minus x square, and then substitute the limit. Therefore, 1 by 2 minus 1, for lower limit it is 0, and therefore 1 by 2 minus 1 nothing but minus 1 by 2, a value of RHS, equation number 4th. And therefore, if we observe the values of equation 3rd and 4th,